Today we will show you some governance-related updates of Traefik Hub, as well as we will give you an overview of Runtime API governance, what it is, what can it do for you. But before we dive deeper, let's start with a quick introduction to Traefik Labs. We are a globally distributed company with deep open source roots. Our Traefik proxy is the top 15 downloaded image on Docker Hub. It's over 3.3 billion downloads, and it has more than 50,000 stars now on GitHub. We are ranking first on open source insights for the API gateway category, and also Gartner is including us in the Magic Quadrant for API management for the last 2 years. We offer enterprise-grade, even mission-critical support for proxy, but we also have some purpose-built tools targeting API publishers. Next slide, please. Here you can see that our product portfolio contains the application proxy, as well as an API gateway and an API management solution. We can expose APIs from any kinds of environments. Let it be hosted on premises, in the cloud, in multiple clouds, or some part local, some part cloud in a hybrid environment. We are compatible with any Kubernetes distribution, and more provide Traefik as the default ingress controller, since it's cloud native and Kubernetes native. But we also support other orchestrators like HashiCorp Nomad or even Docker Swarm, you name it. And this brings us to our secret sauce, GitOps. All our solutions can be configured through declarative configuration, and if that's not enough, all in an additive fashion. It means that if you start your journey with the most well-known proxy, you configure it, you start using it, but you want more enterprise-level features like advanced authentication and authorization capabilities, distributed rate limiting and certificate management, HashiCorp Vault integration for secrets, and so on. You can effortlessly upgrade to API Gateway by executing one Helm upgrade with a new license, and now you can enjoy all benefits of the API Gateway. All your configuration stays the same. The gateway understands all your previous config. It's just more features unlocked now that you can start to use. And it's the same with API management. Execute another Helm upgrade with a new license, and new features are unlocked. You get a developer portal, API metrics, and very powerful API governance, all on top of what you had before. And this brings us to API governance, and specifically to API runtime governance. API governance provides a framework for defining policies and standards to ensure APIs are consistent, compliant, and secure. However, a common misconception about API governance is that it is solely about API design concerns, such as following a specific pagination pattern or ensuring API descriptions adhere to specific linting rules. While these design considerations are important, they are just part of the picture. API governance is not just about defining design standards. It's the backbone to ensure that APIs are consistent, compliant, and secure across their entire lifecycle. Overlooking runtime governance, like monitoring API performance, managing access controls, and enforcing security protocols, can lead to catastrophic failures in production. Given how crucial API governance is to an organization's API strategy success, we created 5 policies we recommend for API teams. API management teams are responsible for defining and enforcing runtime API governance. Runtime API governance is the structured framework that manages and enforces policies for API deployment, security, observability, and lifecycle during their operational phase. It's ensuring that APIs are deployed in a traceable and secure manner with all configurations version controlled and changes managed through a standardized process. This governance also mandates that live APIs be centrally documented, monitored for performance, and secured via gateways and firewalls. Overall, API governance provides a controlled environment to maintain API integrity, security, and efficiency in real-time operations. So let's see briefly how you can handle these with Traefik Hub. The first policy we will cover is the importance of a CI/CD foundation. It's important to use a developer-friendly, traceable, and easy-to-rollback approach for API deployments. The CI/CD pipeline must act as the primary change agent, driving all changes, feedback, and collaborations through automated processes with no manual steps outside the pipeline. By automating these previously manual procedures, the pipeline evolves into an automated knowledge base that outlines the steps that are required to validate and ship working software. Such a pipeline has a profound effect on the team's culture. As we say, changing the pipeline changes the culture. As a Kubernetes native solution, Traefik Hub supports declarative resource configuration through Kubernetes resources like ingress, service, and Traefik custom resource definitions such as ingress route, middleware, API portal, API plan, and so on. Configuration can be version controlled in Git and automatically applied to the cluster using GitOps tools like Argo CD and Flux. The declarative nature of the Traefik configuration, combined with GitOps workflows, supports advanced and progressive deployment capabilities like blue-green and canary releases. If any issues are detected, then changes can be rolled back to a stable version. But good CI/CD pipeline is just the start, as you want to publish APIs after all. The second policy is about making APIs available, but organizations often take it to the extreme and struggle with the uncontrolled proliferation of APIs. It occurs when there is a lack of proper documentation and centralized API governance. It is very important to make the documentation for APIs available to users. But if we are frank, it's not unheard of for organizations to not know where all its APIs are located or what they are used for. And Traefik Hub API management includes an API developer portal for this use case to make API documentation accessible to developers and other API users. In the portal, users can explore available API endpoints, understand their usage, and test them in real time. An API and its documentation will be visible to an API consumer if they belong to a specified group with access to the API, as configured by the API access policy. This means no more shadow APIs, which are unknown, unmanaged APIs, and no more zombie APIs that are no longer actively maintained, supported, or monitored, but are still functional and accessible to users, imposing a huge security risk. And speaking of security, the rapid growth of APIs and API traffic has exponentially expanded the attack surface for malicious actors. This year's State of API Security report from Salt Security states that 95% of the respondents experienced security problems in production APIs, which is basically all of them. It is crucial to protect APIs and invest in API runtime protection to guard against threats resulting from authentication weaknesses, sensitive data exposure, and account takeover or misuse. Public APIs can especially face a host of attack vectors like CQL and code injection to cross-site scripting and other OWASP top 10 API vulnerabilities. With Traefik Hub, you can centralize your API runtime governance and ensure secure API access using protocols such as OAuth2, OpenID Connect, API keys, and JSON Web Tokens. Traefik also integrates with identity providers such as Keycloak and Okta, or any other identity provider that supports the OIDC protocol. Also, using Traefik's distributed rate limit, you can limit requests over time across your entire cluster, rather than just an individual proxy. And recently, we have announced the partnership with the Corazza web application firewall, available as a WASM plugin in the open source proxy and as a highly performant native integration within Hub to let you meet various industry compliance requirements like PCI DSS, HIPAA, or GDPR. But all of these security measures can only be effective if you pay attention to change management, our next policy. Even the best fortresses can lose their effectiveness if you don't pay attention to the cracks appearing on the walls. Traefik Hub helps you understand the impact of API configuration changes by performing static checks on manifest files. It includes a static analyzer tool to check for consistency and quality. This static analyzer can lint manifest files and generate differential reports, so, for example, as a standalone tool or as part of a CI/CD pipeline. It can also be used for change impact analysis, identifying the potential consequences of a change, the components affected, and the possible risk associated with that change. So the changes do not introduce system instability, performance, or security issues. And to aid API evolution, Traefik Hub also supports several API versioning schemes. Teams can define and use API versions based on host, path, HTTP method, query parameters, media type or content type headers, basically any custom headers, the client's IP address, the authenticated user, JOT claims, and even more for API versioning. You can even mix these different versioning schemes based on logical expressions. And to maintain a continuous feedback loop, we arrive at our last policy. You must pursue proactive API monitoring and comprehensive granular observability to reduce time to recovery in case of the unexpected happens. API monitoring involves tracking key metrics of API performance, such as response times and error rates, but also goes beyond performance. Observability allows you to troubleshoot novel problems and understand what is happening inside an application using telemetry signals, metrics, logs, and traces. Debugging has never been easier with open observability standards like OpenTelemetry, guaranteeing compatibility with various API analytics platforms and preventing vendor lock-in. Traefik Hub has the most comprehensive OpenTelemetry support in the industry, with over 20 metrics and 15 labels allowing deep drill down besides detailed tracing. It also supports vendor-specific metric systems such as Prometheus or Datadog. Correlating GitOps deployment events with incident management and API observability enhances your ability to monitor and respond to issues effectively, and improve your mean time to recovery, saving a lot of money by reducing outage times. If you want to know more about these topics, we have published 2 blog posts recently, going deep in the theory, but as well as into the practical side of things. Traefik Hub has a lot of features to help you implement these API runtime governance standards, but today we want to focus on the recent feature additions that will enhance your governance efforts. These are API plans, bundles, and the new traffic debugger. So let's see plans first, how it can improve your runtime governance. First and foremost, plans allow you to centralize policy management, consolidating rate limit and quota enforcement into a single resource, making it easier to maintain and update granular API access policies. Plans streamline the access control by simplifying the association between user groups and APIs through well-defined plans, enhancing your access management efficiency. Also, plans allow you to apply governance consistently. Apply standardized plans like gold, bronze, or silver across all your APIs to ensure a uniform governance and reduce the risk of misconfigurations. The plans in Traefik Hub API management let you configure rate limits and quotas in a distributed fashion, meaning that the counters of the incoming requests are shared across gateway replicas, ensuring that requests are remitted over time throughout your cluster and not only on an individual proxy instance. As you scale up and you have more and more gateway instances, they will share a common state, ensuring a fair distribution of resources among your API consumers. The rate limits control the rate at which requests are allowed over a short period of time. It limits how fast requests can be made by delaying or rejecting excess requests to match the target rate. On the other hand, the quotas define a fixed number of requests allowed over a given period of time. Once the quota limit is reached, further requests are immediately denied until the quota renews. You can look at API plans as business level controls, where you have an explicit or an implicit contract with your customers. However, you can use a multi-layered approach to this piece of runtime governance, as API management has access to all underlying API gateway features too. The ingresses serving your APIs can define overall rate limits to protect your backends from legitimate traffic spikes or even from malicious actors. This way, you can layer business objectives on top of service level protections. Empowered by these capabilities, when you have many consumers, you can ensure that none of them is starved or consumes more than what is needed or what is allowed. However, when you scale out to many APIs, it can become challenging to manage them one by one. This is where we have introduced a new grouping mechanism for APIs to allow you to unify your runtime governance. You can now group one or more APIs under a single API bundle, simplifying reference and access to them across your infrastructure. API plans can be directly applied to API bundles, enabling consistent rate limits and quotas across all the included APIs. Since Traefik Hub is Kubernetes native, including APIs in the bundle is very flexible. You can add APIs to a bundle by explicitly naming them or using Kubernetes native label selectors for dynamic and scalable API management. On the API developer portal, these bundles appear like folders of APIs. So it makes it easier to discover similar APIs grouped together following a common theme to your liking, and can also contribute to a faster time to first API call. And this leads us to our last key feature announcement for today, the new API traffic debugger. It's available for both API gateway and management users. We formed an exclusive partnership with Treblle to provide advanced monitoring and observability for your APIs that is not available anywhere else. With a single click, you can access Trebble's observability and monitoring capabilities directly within Traefik Hub without the need to maintain your own logging infrastructure. You don't need to leave the Hub UI with a seamless onboarding experience to Treblle, but under the hood, the gateway handles everything, including masking sensitive data for privacy. Start using this integration in just a few simple steps. Log into the Hub dashboard, add your Treblle API key and project ID, or register a new account with a single click to get these. Install the Treblle plugin on your gateway, and boom, you can see all your API requests and responses right in the Hub UI. It basically couldn't be simpler than this to unlock real-time API monitoring. You can now gain immediate insights into your API traffic, helping you to identify and address issues as they happen, and allows you to troubleshoot and resolve problems efficiently. Also provides detailed insights into individual API calls and displays response times and other critical metrics to optimize your API. With this traffic debugger, you can improve the reliability and the performance of your APIs, leading to better user experience and increased confidence in your API infrastructure. And all this without investing into maintaining a logging infrastructure or the need to log into a separate dashboard. With all that said, I think this is now time for a demo to see all this in action. Sean, the stage is yours.
Thank you, Emmanuel. That was a great overview of these 3 new features, and we're going to take a look at those new features being plans, bundles, and our traffic debugger. So let's go ahead and take a look at our dashboard. And here, this is the Traefik Hub dashboard that gives you an overview of all your gateways deployed and all APIs that you have in your environment, and helps you provision and debug traffic. I have 1 gateway deployed here for this demo, and I have my local dashboard open for that. And I also have my API portal with 2 APIs deployed, time zone and weather. You can see that the API portal ingests the Open API spec and shows you how to use the API and provides examples here. So we're going to take a look at the gateway here. I have these 2 APIs, as I mentioned. And we're going to start with plans. You can see how I don't have any plans here. So let's go to our console. And here I have an API definition API access and ingress route. So if you're familiar with Traefik, the ingress route is the traffic-specific CRD that provides the ingress capabilities and load balancing and reverse proxy to a service. And so with the API management offering from Traefik, we've added additional CRDs that allow you to work with APIs directly in your config. And so here we have our weather API, and you can see that's an API type object. And we have our API spec associated with that. And then here we have our API access, and the API access brings together the groups, who's going to access this API, the APIs that you are working with here, and any kind of plans or that you're associating with that. And then if I scroll down, I can see the ingress route, which is your standard Traefik ingress route, except we have the API associated with that here. So it gives you an overview of how you define an API, set the access, and associate that with a standard ingress route. So here we see a standard request. We issued an API request to our weather API. We get a 200 request or a response. Looks good. So now I want to associate a plan, and the plan is going to associate a quota and or a rate limit, and you're going to give that a name. So in here, this is assigned, or created specifically for external users. And if we look at the API access definition, similar to the one we had previously, the differences here are we have this plan associated, and we've assigned a weight. And so with plans and your APIs, you're going to have many different users with different groups associated with them. You're going to have many APIs, and you're probably going to have multiple plans, like a gold, silver plan, or different configuration for different levels of access or different SLAs. And when you have all these configured, there's a chance that multiple plans or API access would be associated with the same user or same request. And so the weight allows you to determine which one will be applied. And so we see this API plan limits the quota to 5 requests in a 24-hour period. So now if we issue those requests, we can see that we've associated that and applied it to our cluster. So let's issue those requests. And you can see as I start issuing these requests, we get some additional information, right? Quota remaining. And you can see, oh, I've already exceeded my quota for the day. So I got to wait 24 hours to get additional requests based on that quota. So let's assign another quota or API access and plan. This one will be a premium plan, which is 500 requests in a 24-hour period. And we're giving it a weight of 4, so it's going to have a higher weight. So this API access and plan is going to be applied to the user instead of the previous one. And so it won't be 505 requests as my quota. It will be 500 because this has the higher weight. And you can see the requests remaining is much higher, and shows you how that API plan is applied. So now let's look at another API, because that's a configuration for a single API. But as we talked about with bundles, it's an easy way to apply a plan and policies to a group of APIs, which is really needed for scale. So here we've created a bundle called the city bundle, and I've named these two APIs that will be associated. But at scale, you're not going to want to add every single API by name here. What you can do is label the APIs as they're added, and then associate a label with a bundle. And so that will be built dynamically and much more efficiently. But here in this plan, you can see I have a rate limit of 20 requests a second and a quota of 20,000 requests in a month. And we can see I have the higher weight, I have the VPI plan, and we have our bundle instead of a named API. So we've applied those. And now when I issue requests, you can see that I'm actually flipping between the time zone API and the weather API with these requests, and the quota remaining is going down 1. And so you can see this is all from the same bucket from the same plan. And actually, going next to the debugger, this is the config that covers that. It basically you have your middleware associated that. And if we now switch over to our hub dashboard, you can see that the plans that I had created are available here. And with this dashboard, you can actually do operations and create plans, delete plans, and associate them with the gateway here. But through GitOps workflow, you can do that through CRDs, which is going to be much easier to scale. So when we take a look at the Traefik debugger, so I've issued all these API requests, and now you can see them here in the debugger. And you can see the load time, response size. You can see, we can dig in and see have the response code, and not just standard log data like headers or something like that, but actually get into the request data and response data as well. And so this is really useful for troubleshooting. And when we look at the headers in the request, we can see that the authorization header and the email address have been masked. Now, this is important because you're most likely going to have some kind of sensitive information in your APIs. And so you can easily mask that so it's not available in the Traefik debugger because this is a cloud-based offering. So I hope this is a good overview for you for the 3 new features, talking about bundles, plans, and our Traefik debugger.